Hello, my name is Lisa Zhao, and I am an undergraduate researcher at Michigan State University. The title of my poster is The Dysregulation of Cholesterol Metabolism and its Implication in Neurological Diseases. The human brain contains up to 25% of cholesterol in the body, where cholesterol makes up to 2% of the brain. The crucial role of lipids and cholesterol in brain tissue physiology and cell signaling is demonstrated by many neurological disorders, including bipolar disorders and schizophrenia, and neurodegenerative diseases such as Alzheimer's, Parkinson's, Lehmann-Pick, and Huntington diseases that involve deregulated lipid metabolism. Occurrences such as oxidative stress and lipid peroxidation can disrupt the balance of cholesterol, characterizing damages of vast clinical importance. The aim of this study was to evaluate cholesterol alterations in human brains at different clinical stages and its association with brain aging. Regarding the methodology, to determine the cholesterol content of the brain samples, the first step was sterile extraction, where the lipids were extracted from the brain tissue. The next step is saponification. Fatty acids are washed out from the lipid solution. The resulting lipids are purified and enriched through solid phase extraction. Finally, the enriched sample is salinized and prepared for injection into the gas chromatography mass spectrometer, the GCMS. By integrating the cholesterol in standard peaks in the chromatograms, the cholesterol content, micrograms per milligram sample, can be determined. Figures 2 and 7 show the sample chromatograms obtained from the samples. The section of my experimental scheme in Figure 1 within the red lines highlights the protocols that were currently performed. The rest of the experimental scheme will be future steps for analysis of the brain tissue samples. A one-way ANOVA was used to evaluate differences between control and illness tissues using SPSS version 27 IBM. The difference was found to be statistically significant between healthy and illness brain cholesterol content in Figure 3. This indicates that regular cholesterol metabolism was impacted in the illness brain samples. A decrease in cholesterol levels in the brain is a biomarker of neurodegenerative diseases. The difference was found to be statistically significant between the frontal, occipital, and cerebellum sections of the illness brain samples. The occipital cortex relates to visual processing and hand-eye coordination, while the cerebellum deals with motor function, along with coordination and regulation of muscular activity. The decrease of cholesterol observed in the occipital and cerebellum sections of illness brain samples indicates that those regions and their respective functions were negatively impacted. There was no statistically significant difference determined between the frontal, occipital, and cerebellum sections of the control brain samples. There was no statistically significant difference between the age sections for both healthy and illness brain samples as is observed in Figure 5. Similarly, there was no statistically significant difference between female and male brains as shown in Figure 6. Statistical tests also indicate that there is an interaction between the age factor and sex factor within the healthy cholesterol data. Within the illness cholesterol data, statistical tests indicate that the age sections factor has interactions with the sex factor and brain sections factor. Regarding future works, the next step would be to determine the cholesterol oxidation products, the COPs, content in the brain tissue samples. Furthermore, DNA fractionation will be performed to study potential intracellular differences between illness and control brain tissue samples. Thank you so much for watching.